11 billion miles from Earth, a spacecraft crossed into a region of space that should have been calm, cold, and predictable. Instead, its instruments recorded something that made scientists genuinely uneasy: a sudden spike in radiation, a magnetic field pointing in a direction physics said it should not point, and a wall of plasma burning hotter than anything researchers expected to find in the supposedly empty void beyond our solar system. NASA confirmed every bit of it. This was not a glitch. This was real data, and it revealed that interstellar space is far stranger and far less predictable than anyone had prepared for. We are talking about Voyager 2, the genuinely unsettling discoveries its instruments made the moment it crossed into true interstellar space. Before you brace yourself for something out of a horror movie, let's be clear about something important. Nothing here involves aliens, hidden transmissions, or secret cover-ups, despite what some corners of the internet might try to tell you. What Voyager 2 actually found is something scarier in a much more scientific sense. Proof that the boundary of our entire solar system behaves in ways that directly contradicted what researchers had confidently predicted for decades. Stick around, because the real story here is unsettling enough without any exaggeration at all. Let's set the stage properly first. Voyager 2 launched in August of 1977, eventually becoming the only spacecraft in history to fly, past all 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. After finishing that historic tour, it kept traveling outward, and on November 5th, 2018, it officially crossed the heliopause, the boundary marking the true edge of our solar system, where the sun's constant outward stream of charged particles finally loses its grip against the surrounding galaxy. This made Voyager 2 only the second human-made object in history to leave the protective bubble surrounding our entire solar system, following its twin, Voyager 1, which made the same crossing back in 2012. 1 year later, on November 4th, 2019, NASA formally released the results of that crossing in 5 separate papers published in the journal Nature Astronomy. And what those papers revealed genuinely surprised the scientists who had spent decades building models to predict exactly what this moment would look like. Quick pause here. If genuinely strange, scientifically verified discoveries are your thing, go ahead and tap that like button right now. It costs nothing, and it really does help this channel keep making videos exactly like this one. Here is the first unsettling detail. As Voyager 2 approached the boundary, its cosmic ray detector picked up something researchers did not expect to see happen so abruptly. Cosmic rays, high-energy particles that originate from exploding stars and other violent events deep in the galaxy, are normally partially blocked by our sun's protective bubble, the heliosphere. As Voyager 2 crossed into interstellar space, the rate of cosmic rays striking its instruments suddenly spiked, jumping sharply the moment it left the sun's shielding influence behind. On its own, that spike was expected in principle. What unsettled researchers was how sharp and immediate the increase actually was, confirming that the boundary between our solar system and interstellar space is a far more abrupt, far less gradual transition than earlier theoretical models had suggested. Then came the plasma temperature reading. And this is where things get genuinely strange. Scientists measured the temperature of the plasma surrounding Voyager 2 once it crossed fully into interstellar space, and the result came back at over 54,000 degrees Fahrenheit, dramatically hotter than researchers had predicted for this supposedly empty, quiet region of space. And yet, despite that scorching reading, the environment immediately around the spacecraft remained bitterly cold, because the plasma out there is so thin and sparsely populated with particles that raw temperature alone tells only part of the story. It is a genuinely disorienting contradiction, a region of space simultaneously blisteringly hot by one measurement and freezing cold by another, depending entirely on which physical property you choose to measure. If you're new here and enjoy content that treats real scientific mystery with the seriousness it deserves, now would be a great time to hit that subscribe button, because there is a lot more of this waiting for you. The magnetic field data turned out to be even more unsettling to researchers who had spent years building theoretical models of what this boundary should look like. Scientists had confidently predicted that once Voyager 2 crossed fully into interstellar space, the direction of the surrounding magnetic field would shift dramatically, marking a clean, unmistakable line between the sun's territory and the rest of the galaxy. Instead, the magnetic field barely changed direction at all, remaining tilted at an angle nobody had properly predicted. This same puzzling result had already shown up in Voyager 1's data years earlier, but with only one data point available at the time, scientists could not be certain whether it was a genuine feature of interstellar space or simply a fluke tied to wherever Voyager 1 happened to cross. When Voyager 2 crossed at a completely different location and found the exact same unexpected alignment, it confirmed something researchers found genuinely difficult to explain using existing models: that our solar system's magnetic field appears to be leaking outward, bleeding into interstellar space far beyond where anyone expected it to stop. Perhaps the most disorienting discovery of all involved how the boundary itself behaved during the crossing. Researchers expected the heliopause to act like a clean one-way barrier, sealing our solar system completely apart from the interstellar medium surrounding it. Voyager 1's data had shown interstellar particles leaking inward on 2 separate occasions shortly before its own crossing. Voyager 2 revealed something almost the opposite, detecting solar particles continuing to leak outward, lingering in the region even after the spacecraft had technically already crossed into interstellar space. In other words, the boundary humanity had spent decades imagining as a tidy, simple wall turned out to be leaking in both directions, at different times, in different places, behaving nothing like the clean, predictable line found in textbook diagrams. This is exactly the kind of finding that makes scientists uneasy in the best, most productive sense of that word. Ed Stone, who served as Voyager's project scientist for decades, acknowledged that there remains an enormous amount left to learn about the region immediately beyond the heliopause, even now, with 2 working spacecraft having already crossed it directly. That kind of honest uncertainty, coming from one of the most experienced scientists ever involved with this mission, says a great deal about just how much of interstellar space genuinely remains unexplained, even after gathering direct, hard-won measurements from the very edge of our solar system. Later research, using an additional NASA mission called the Interstellar Boundary Explorer, added yet another unsettling layer to this picture. By studying particles bouncing back from the heliopause over several months in 2014, researchers discovered that the boundary was not simply misbehaving in a fixed, predictable way. It appeared to be actively rippling, shifting and expanding and contracting over surprisingly short periods of time, almost like the entire structure was breathing in response to pressure changes, coming from our own sun. Combined with the Voyager data, this research confirmed that our solar system's edge is nowhere near as smooth, stable, or symmetrical as the simplified diagrams found in most science textbooks would suggest. Researchers also confirmed that the interstellar magnetic field itself turned out to be significantly stronger than models had predicted, measuring roughly 2 to 3 times more powerful than expected. That stronger field means interstellar particles are pushing back against our sun's protective bubble with as much as 10 times more pressure than scientists had originally calculated. This detail alone forced researchers to reconsider the overall shape, stability, and long-term behavior of the heliosphere, the very bubble that shields Earth and everything living on it from a significant portion of the harmful cosmic radiation constantly drifting through the galaxy. That is really the heart of why this story unsettled so many researchers, even though nothing about it involves anything supernatural or artificial. Every single assumption scientists had confidently built into their models over decades turned out to be at least partially wrong. The boundary was not clean, the magnetic field did not behave as predicted, the temperature contradicted intuition, and the entire structure appeared to shift and breathe in ways nobody had properly accounted for. For a field of science built on careful, predictive modeling, discovering that reality diverges this significantly from expectation is genuinely humbling and more than a little unsettling, in the most scientifically honest sense of that word. It also helps to understand exactly why scientists build predictive models in the first place, and why having those models proven wrong feels so genuinely significant to the people who study this field. Before Voyager 2 ever reached the heliopause, researchers had spent decades constructing detailed theoretical simulations of what the boundary of our solar system should look like, based on known physics, computer modeling, and comparisons with similar structures observed around other stars. Those models were not guesses. They represented some of the best available science, built by experienced researchers using the most advanced tools available at the time. When real, direct measurements from Voyager 2 diverged this significantly from those careful predictions, it did not mean the earlier scientists had done sloppy work. It meant interstellar space itself contains genuine complexity that simply cannot be fully captured by remote observation and theoretical modeling alone, no matter how sophisticated those models eventually become. This is precisely why direct, in situ measurement, actually sending an instrument into a region of space rather than just observing it from a distance, remains so scientifically valuable, even when it is slow, difficult, and takes decades to accomplish. Telescopes can observe distant stars, even other star systems from millions or billions of miles away, gathering enormous amounts of useful information. But there are some things about a specific physical region of space that can only be learned by actually sending an instrument directly into it, measuring the exact conditions on site, rather than inferring them indirectly from a distance. Voyager 2's uncomfortable, model-breaking discoveries are exactly the kind of finding that direct measurement uniquely makes possible. There's also something worth appreciating about how transparently this entire process played out. NASA did not attempt to downplay or hide how significantly reality diverged from prior expectations. The 5 papers published in Nature Astronomy in November of 2019 documented these surprising findings openly in a peer-reviewed scientific journal available for any other researcher in the world to examine, challenge, or build upon. That kind of open, honest reporting of results that contradict prior predictions is exactly what separates legitimate scientific discovery from the kind of sensationalized, unverified claims that circulate constantly across less reputable corners of the internet, the kind that invent secret transmissions, hidden messages, or classified cover-ups without a shred of actual verifiable evidence behind any of it. That distinction matters enormously, especially given how much misleading content has spread online specifically about Voyager 2 in recent years. Multiple blogs and social media accounts have published entirely fabricated stories claiming NASA secretly detected artificial signals, coded transmissions, or evidence of alien contact from Voyager 2, often inventing fake quotes attributed to scientists who never actually said anything resembling those claims. These stories spread specifically because they sound exciting, tapping into genuine, real uncertainty about deep space in order to sell a far more sensational, entirely invented narrative. But the real story, the one grounded in actual published research, does not need any of that fabrication to be genuinely compelling. Reality, once again, turned out to be strange enough entirely on its own. None of this changes the basic, confirmed facts of the mission, though. Voyager 2 is not broadcasting mysterious coded messages. It has not encountered anything resembling an artificial structure or an unknown intelligence. Every strange, unsettling detail covered in this video comes directly from peer-reviewed research published in a respected scientific journal, gathered using real instruments still functioning after nearly 50 years in space. The genuine strangeness here does not need any exaggeration or fabrication, because the true documented reality of interstellar space already turned out to be more surprising than anyone confidently predicted going in. That reality also raises a broader, genuinely uncomfortable question worth sitting with for a moment. If our own solar system's boundary, the closest and most directly studied edge of interstellar space humanity has ever measured, still managed to defy careful, decades-old predictions. This, significantly, what does that say about our confidence in models describing far more distant, far less directly studied regions of the galaxy? Every other boundary, every other theoretical structure, astronomers have. Mapped using indirect observation from telescopes rather than direct spacecraft measurement, may be hiding similarly unexpected complexity, simply waiting for humanity to finally get close enough to check. Decades, or even centuries from now, using instruments and missions nobody has even designed yet, built by scientists who have not been born yet either. Both Voyager spacecraft continue facing a very real limitation as they keep gathering this kind of data. Their radioactive power sources have been steadily decaying since launch, forcing NASA engineers to permanently shut down instrument after instrument just to keep both spacecraft transmitting at all. Current estimates suggest both Voyagers likely have only a handful of years of meaningful operation left, meaning whatever additional secrets interstellar space is still hiding may need to wait decades longer before any other spacecraft gets close enough to investigate directly again. If this story left you genuinely unsettled in the best, most scientifically honest way possible, make sure you are subscribed with notifications turned on, because Voyager 2 is still out there right now, still transmitting, and there is a very good chance its next signal reveals another assumption about interstellar space that turns out to be wrong. Sometimes the most disorienting discoveries in science are not the ones involving aliens or hidden messages at all. Sometimes they are simply the moment when reality quietly refuses to match the careful predictions built by some of the smartest people on the planet, and that, in its own way, might be the most honestly unsettling kind of discovery there is.